All right, let's jump right in. If you're in software, you know the deal. You live and breathe logic, code, execution. But here's the thing. Every single technical decision you make, it doesn't exist in a vacuum. It exists in the real world of business, of budgets, of value. And the biggest challenge? It's building a bridge between those two worlds. So think of this explainer as the blueprint for that exact bridge. We're going to break down how to use the principles of engineering economy to make software decisions that are not just technically sound, but are also smart business.
And this image, well, it gets right to the heart of the problem, doesn't it? When you build a physical bridge, you can see the progress. You see steel going up, concrete being poured. It's real, it's tangible. But with software, the progress is, well, it's invisible, right? It's just lines of code, abstract logic, until the very end. This is exactly why estimating things in software is so incredibly tricky, and why our projects are so famously hard to predict.
So because software is this really unique, kinda intangible beast, we just can't rely on gut feelings. And we can't just pick what's technically the coolest or most pure solution. We need a much more rigorous way of thinking.
And this right here, this is the core mindset shift we have to make. You have to stop thinking of software development as just some technical task. It is a capital investment. You're taking limited resources, your team's time, their talent, actual cold, hard cash, and you are investing it to create a product. And that means every function you write, every library you choose, it's a financial decision. Every single one has a potential return on investment.
So, okay, how do we actually navigate all this? Well, we adopt what's called an economic mindset. Now, this isn't about you becoming an accountant overnight, don't worry. It's about using a rational, logical framework to make better and, frankly, more justifiable engineering decisions.
And that framework has a name: engineering economy. And listen, the most important word in that definition is systematic. This is the exact opposite of guesswork. It's a structured process for weighing the costs and benefits of all your different technical options to find the one that provides the most actual value.
At its core, the mission is a balancing act. On one side of the scale, you've got all the technical stuff we love to argue about. Is it fast? Is it reliable? Is it secure? But on the other side, you've got the economic reality. How much does it cost to build? What's the long-term cost to maintain it? What about getting rid of it someday? The goal isn't for one side to win. The goal is to find the perfect balance between them.
Which brings us to the one question that rules them all. Seriously, every single decision, from choosing a JavaScript framework to designing a database, it has to answer this one simple, powerful question. Is the long-term benefit of using some brand new, super fast framework really worth the long-term cost of having a tiny hiring pool and maybe no community support? If the answer is no, you got to find another way.
Okay, so we've got the mindset down. Now let's get into the playbook. How do we actually put this stuff into practice?
And what's great is that the framework is beautifully simple, and it's a cycle. Step 1, define the problem. Let's say, we need to cut our page load time in half. Step 2, identify alternatives. You could say, optimize the current code, or maybe migrate to a new CDN, or even totally re-architect the front end. Step 3, you estimate the costs and the benefits for each of those options. And finally, step 4, using the same criteria for all of them, you select the best alternative. Then you just repeat the process for your next big decision.
But, to make that 4-step cycle really work, it's guided by 7 core principles. You can think of these as the guardrails, the rules of the road that keep you making sound, rational choices.
The first 3 are just foundational. Number 1, develop alternatives. Look, a decision is only as good as the options you consider. If you need a chat feature, don't just automatically assume you have to build it from scratch. Maybe integrating a third-party API is a viable alternative. Number 2, focus on the differences. If both your in-house option and the API are going to run on the same servers, then server cost doesn't matter for the decision. You only compare what's actually different, like the upfront development time versus the ongoing licensing fees. And 3, use a consistent viewpoint. A feature that's amazing for your users might be an absolute nightmare for your operations team to maintain. You have to decide whose perspective you're optimizing for.
The next 4 principles add even more rigor. Number 4, use a common unit of measure. And let's be real, that's almost always going to be dollars. You have to ask, what is improved user satisfaction actually worth in terms of dollars from reduced churn or more signups? Quantify it. 5, consider all criteria. That includes the non-monetary stuff. A technically worse solution might be the right call if it massively boosts team morale and helps you keep your best people. 6. Make risk explicit. What are the odds your chosen database vendor goes out of business in 3 years? Acknowledge it, write it down. And finally, my favorite, number 7, revisit your decisions. Look back. Did the project actually deliver the value you expected? This feedback loop is what makes you better and better at this over time.
All right, you've got the mindset, you've got the playbook. Now let's fill up your toolkit with a few essential economic concepts that you're going to use all the time.
This iceberg visual, it's perfect because we always focus on the cost to build something. That's the tip of the iceberg, the acquisition phase. But the real cost, the total cost of ownership, is that massive chunk of ice hiding below the water. That's the operation phase. We're talking maintenance, support, bug fixes, updates. It's huge, and it can go on for years. A solution that was cheap to build but is a total nightmare to maintain? That's actually the most expensive choice you can make.
Now, to understand that iceberg, you gotta know your costs. Fixed costs are things that don't change no matter what. Think your software licenses or the servers you buy. Then there are variable costs. These go up with activity, like your cloud hosting bill that climbs with every new user you sign up. And then there's the most important one, the one that trips everyone up, sunk costs.
Sunk costs are money you've already spent that you can never get back. And here's the crucial part. They are completely, 100% irrelevant to any future decisions. It doesn't matter if you've already spent 6 months and $1 million on a project. If you find out today that it's the wrong path, the only rational choice is to stop. Plowing ahead just because of what you've already invested? That's a classic trap called throwing good money after bad.
The last tool for your kit is the time value of money. It's a simple idea. $100 today is worth more than $100 a year from now. Why? Because you could invest today's $100 and earn interest on it. So, for example, paying a $20,000 license fee every year for 5 years is actually way cheaper in today's money than paying $100,000 for a license up front.
So, let's bring it all home. We've talked about the mindset, we've walked through the playbook, and we've filled the toolkit. Now let's see how it all clicks together into one single, rational process.
Here it is. This is the whole process. First, you clearly define the need. Second, for every alternative you're considering, you estimate its entire lifecycle cost. That's the whole iceberg we talked about. Third, you adjust all those future costs and benefits for the time value of money to see what they're really worth today. And only then, fourth, do you compare your alternatives. It's a true apples-to-apples comparison that lets you make a rational, data-driven choice, free from emotion and gut feelings.
So, I'll leave you with this question. The next time you have to choose a technology, or architect a new system, or even just decide how to tackle a user story, you have a choice. You can go with your gut, you can do what's familiar, or you can use this framework. So will you be guessing, or will you be investing?